Today we are sharing with you classified information on the cycle known as Krebs. Generally, the Krebs cycle is well respected in the metabolic community. Krebs is involved in energy production, and most see that as a good thing. We have had some concerns raised lately from the public though, and we are asking you to investigate further. As I mentioned, being part of the energy production process is generally seen as a good thing, but when you're involved in a process that takes something that looks like this, and ultimately has it come out looking like this, I can see how people could get concerned. So let's dig in. The Krebs cycle has two known aliases. These days, the Krebs is also going by CAC and TCA. Pretty tricky, right? Let's get a look at this cycle. Very funny. Krebs is not that kind of cycle. Krebs is this kind of cycle. Have a few seconds to take that all in. Now, Krebs is known to get down to business in two different places. The Krebs cycle runs in the mitochondria of eukaryotes or the cytosol of prokaryotes, which you see on your right-hand side there. And Krebs has a pretty complicated MO. Let's take a look. Initially, before the Krebs cycle even becomes involved, glucose is split into two pyruvate. The pyruvate is oxidized in the Krebs cycle into acetyl-CoA, producing CO2 and NADH. Acetyl-CoA combines with oxaloacetate to form citrate. The citrate is isomerized into isocitrate. Isocitrate is oxidized into alpha-ketoglutarate, producing CO2. NAD is reduced to NADH. Let's get another look at this cycle. As I said, pretty intense. Continuing on with the MO, alpha-ketoglutarate is then converted into succinyl-CoA. NAD is reduced to NADH, and CO2 is released. Succinyl-CoA is converted to succinate, GDP is produced, succinate is converted to fumarate, QH2 is produced and used to make FADH, fumarate becomes malate, malate becomes oxalacetate, NAD is again reduced to NADH. Remember, each molecule of glucose breaks down into two pyruvate, so the cycle runs twice, ultimately producing 6 NADH, 2 FADH2, 2 GDP, and 4 CO2. The NADH and the FADH2 feed into the electron transport chain, which looks a little something like this, ultimately producing, wait for it, ATP. Good thing, bad thing, I'll let you investigate further and decide. Thanks for your time today.